This is a question from the topic relative velocity that is being asked in the IIT JEE. So what is the question? On a frictionless horizontal surface assumed to be xy plane, a small trolley A is there which is moving along a straight line parallel to y-axis. Okay, this A is a trolley which is moving parallel to y-axis with a speed. Let us suppose the speed of this trolley is Vt. With respect to ground it is given, so it is given as root 3 minus 1 meter per second in j cap direction, y-axis. At a particular instant, when the line OA makes an angle 45 degree, O is the origin here with the x-axis, a small ball is thrown along the surface from the origin O. Its velocity makes an angle phi with the x-axis and it hits the trolley. Okay. So here in the question, from this point O, a small ball is being thrown towards this trolley O, and in the ground frame, let us suppose that this is the scene, this is y-axis, this is x-axis, this is x, this is y. Okay. This is the trolley moving, this is trolley T, and from here let us suppose a ball is thrown with a speed v, and the speed v is making an angle phi with the x-axis in the ground frame. So let us resolve it in the components parallel to x and y-axis. We can write the velocity of this ball b, with respect to ground, that will be equal to v cos phi I cap plus v sin phi j cap. Okay, so here we got two equations. One is the velocity of this trolley with respect to ground, and one is the velocity of this ball with respect to ground. So what is being the question asked? A part is the motion of the ball is observed from the frame of the trolley. Calculate the angle theta made by the velocity vector of the ball with the x-axis in this frame. So okay, this is a simple question actually. So this is the A part, this is our y-axis, this is our x-axis, sorry, this is x, this is y. So this is the trolley moving with some speed, and from here point O, a ball is being thrown. So when we observe this ball from this trolley frame reference, what we will see is, if this ball is being hit by this trolley and if this ball is hitting the trolley, then from the reference frame of this trolley, the velocity of ball with respect to this trolley should always be along the direction parallel to this OA, or we will not say parallel to this OA, it will always be along the OA, along it. Okay, so this is our point O here and this is the A. So this ball is hitting this trolley, then in frame reference of the trolley, this the velocity of this ball with respect to this trolley is always along this OA. So this angle made by the velocity of ball with respect to trolley in trolley frame reference will always be equal to 45 degree. So here we got the answer that theta will always be equal to 45 degree. Okay. Now coming to the next point, next B part, what is asked in the B part, find the speed of the ball with respect to the surface. That means in the ground frame we have to calculate the speed of this ball. If phi is equal to 4 theta by 3. Okay, so we have calculated the velocity of ball with respect to ground here and velocity of this trolley with respect to ground. So let us pause. Velocity of this ball with respect to trolley, we can write velocity of ball with respect to ground minus velocity of trolley with respect to ground. So from the equation 1 and 2 I will substitute the values. Here I will get v cos phi I cap plus v sin phi minus root 3 minus 1, and this complete is along j cap direction. Okay, so let us resolve more. V cos phi I cap plus v sin phi minus root 3 plus 1 j cap. So this is the velocity of ball with respect to trolley in the ground frame. Okay, so as we have solved in the question number 1 that theta is equal to 45 degree, and in the second part it is given that phi is equal to 4 theta by 3. So this phi will be equal to 4 multiply 45 divided by 3. So that will be equal to 60 degree. 60 degree. Okay. So again we can write this equation that velocity of ball with respect to trolley, that will be equal to v cos 60 degree I cap plus v sin 60 degree minus root 3 plus 1 j cap. Okay, so substituting the values of cos 60 degree and sin 60 degree, we will be getting v by 2 I cap plus root 3 v by 2 minus root 3 plus 1 j cap. This is the velocity of ball with respect to trolley. Okay, so as we have solved in the part 1 that this velocity of ball with respect to trolley is always along this line OA. So this is the point O, this is the point A. Here trolley is moving in the upward direction parallel to y-axis. This is the y-axis, this is x. So this line OA is always making an angle of 45 degree. Okay, so in this velocity of ball with respect to trolley, we can write that a component of this velocity is along x-axis like this, that is v by 2, and a component of vbt is along y-axis, that is like root 3 by 2 v minus root 3 plus 1. Okay, and this is the resultant velocity of ball with respect to trolley, right? And this angle is being given as 45 degree. So in this triangle we can use the tangent theta is equal to perpendicular by base. So I will be directly using that in this triangle tangent theta will be equal to Vy divided by Vx, the component of velocity along the x direction. So substituting the value of theta is equal to 45 degree. So tangent 45 will be equal to, what is the value of Vy here, that is root 3 by 2 V minus root 3 plus 1, okay, divided by Vx. What is the value of Vx here? That is V by 2. Okay. So here we will be getting tangent 45 is equal to 1 multiply V by 2, that will be equal to root 3 by 2 V minus root 3 plus 1. So solving this equation, we will get root 3 minus 1 V by 2, that will be equal to root 3 minus 1. So this root 3 minus 1 will be cancelled out and we will be getting V is equal to 2 meter per second. So this is our final answer for this question B. So the velocity of this ball B in the ground frame will be equal to 2 meter per second. We are not talking about the direction here, we are just calculating the magnitude. So it is the magnitude of the velocity of ball with respect to ground.